Yeah. Uh, Good evening, all. Madam, you can introduce the resource person today.
Okay, sir. A very good evening to one and all. Myself, I am Lohita from EC Department of Brilliant Institute of Engineering and Technology. Once again, I welcome you all for the 4th day of online ATAL FDP program on emerging trends in VLSI design for signal processing and communication system. Let me introduce our today's resource person, Dr. Suresh Merugu, sir. Sir is Associate Professor of University, Southampton, Malaysia, UOSM. Dr. Suresh Merugu sir earned his PhD from Indian Institute of Technology, Roorkee. He has around 20 years of teaching experience and equivalent amount of research experience in areas such as advanced digital image processing, colorimetry, computer vision, subpixel classification, data mining techniques, AIML, and space sciences. Dr. Merugu sir has authored and published over 65 papers in various renowned international and national journals and conferences. He also serves as a reviewer for several prestigious international and national journals and conferences. Currently, he is supervising one PhD scholar and has guided one PhD scholar and more than 20 MTech and many graduation theses. Dr. Suresh Merugu sir, as principal investigator, has worked on and completed research projects in various domains and several papers he has. So those are granted utility patent general number, system and method to identify accurate location of expenses. It is having the application number 202041037906 and it is granted on date 27/10/2022 and granted design patent with application number 3575320001. It is having the topic that is a robotic wheel platform for thermal scanning and sanitization. It is filling date on 28/1/2022 and CBR number 212683 and granted date 14/3/2024. And one more, granted design patent with application number 3590200001. It is having the topic Bluetooth communication control device for electromechanical device, filled on 21/2/2022, CBR number 213694. It is granted on 26/4/2022. And Dr. Suresh Merugu sir received IEEE Hyderabad Humanitarian Technology Leadership Award for the year 2020. And sir's research work is, he have extensive experience working on a variety of projects and he have guided students in integrated these technologies into their projects across diverse domains. He have worked on numerous projects and mentored students in the specialized domains of image processing, computer vision, machine learning, and Internet of Things using OpenCV. Image processing involves enhancing visual data and extracting valuable insights, while computer vision focuses on enabling computer to interpret visual information akin to human vision. In machine learning, he have guided students in creating systems that learn and make predictions from the data autonomously. Additionally, he have delved into IoT, connecting physical devices into the internet for data exchange and remote control. Throughout these endeavors, OpenCV has a valuable tool providing a wide array of functions for tasks like image manipulation, object detection, and feature extraction within various project domains. Sir, it is our privilege to have you as a part of this FTB program.
Okay.
Thank you, sir.
Yeah, thank you, Lohita. Thank you so
Over
much.
to you, sir.
Am I audible?
Yes, sir.
Yes, sir.
My,
Yes, sir.
my screen is visible?
Yes, sir.
Yes,
Yeah,
sir.
yeah. Yeah, thank you, Lohita. Thank you so much. And thank you,
Thank you, sir.
Naraya, for inviting me for this ATAL online FDP program, especially on emerging trends in VLSI design, especially by using signal processing and communication systems. Okay, good evening all. So today I just want to highlight about in medical, especially in healthcare, how exactly the signal processing and communication are leading the position. Like already AI and ML are already there, but along with this, where exactly the signal processing and communication techniques are using. So this is what I would like to highlight. So because within this duration of time we can't cover all, but I can give you the overview and exactly how it will work and a few applications what we have done through our research with my students, and that also I'm going to share with you all. Okay, so if you have any questions you can ask me later. And not only that, even if we can also have network, want to have networking, we can have collaborative work also we can do in future. So for that also I welcome everyone, so we can work together. So I'm open to work with you all. So that is what I would like to convey to you all. So coming to today's topic, that is about revolutionizing like healthcare with signal processing and communication techniques, right? So here I will take just like this, I'll go in like introduction to healthcare revolution, how exactly it is taking place, and what are the advanced like signal processing techniques will be used, and how they're already using. Okay, especially in terms of EEG, ECG, how exactly they're using, and how the noise control levels have been taken care. These things we'll see, and after that, cutting edge communication technologies we'll see brief like how exactly and how they are using. And here I'm going to cover about the applications in specific healthcare areas. So in which domain we can plan and we can work. Even you can also guide your students and how later how they can take it forward. If any MTech students also there, you can also think in which direction you want to work, or otherwise you're ready to work on your master thesis. So on that also you get an idea, or otherwise if you want some guidance also you can write to me. Later I will share my email. Otherwise through Naraya also you can, Dr. Naraya also you can reach to me, no worry about that. And challenges and futures directions, how exactly, that also I'll show you. And next the conclusions, especially embracing the connected healthcare future, how exactly we're going to do, and I'll conclude with some references. Okay, so am I audible to all? So can I go ahead with this? If I go
Yes.
speed also you can say, right?
Yeah, yes.
Okay.
Yes.
Yeah, thank you so much. Coming to the first part one, I'm going to cover about the digital healthcare revolution, how exactly. So here, when we talk about healthcare, it means first we have to see about the challenges, like healthcare challenges overview, how exactly we have to work. So like first, I can, means even I'm also being an academician as well as for being a researcher, first we have to see where exactly. So where our expertise is required. So these things we have to see, and where exactly the application is needed, or otherwise need-based problem solving also to be identified in that particular time. So at that particular moment, or otherwise at that particular place. So that also we have to think. With that, with our expertise, how we can resolve that through engineering exploration. So like that we have to come up. So here, when we see like a rising cost, this is the one first most important point, right? So rising cost everywhere we can see, right? Nowadays, everywhere due to inflation or otherwise due to other activities, everywhere the price rising, there is a cost rise in everywhere, right? Aging population. So many, especially only in India, we have youth population is more, but as compared to youth also, there is a aging problem. Means many aging populations also, many aged people also there. So how like many problems like some due to our day-to-day activities or day-to-day work timings, or otherwise due to some other stress and other activities also, many people are undergoing some chronic diseases, right? So like due to some other problems like chronic also I can say, and not only that, geriatric or otherwise dementia problems also we are seeing, right? Even the government of India is also ready to give fund on these domains if you come up with some plug and play model type like assistive devices like such through our technical domain like what you have. correct? So with your expertise, how you can resolve those problems can be taken care, and for that you may get funding also from various funding agencies which are already they're providing, right? So like chronic disease training resources, signaling need for innovative solutions wherever you have, correct? So in this later, if you want, I can also help you. Means what are the funding agencies are available, national or international also. Otherwise later I'll share with Naraya and Dr. Naraya. So Naraya will share with you all. Okay, so this is the first problem, global healthcare burden. This is the first point what I felt that is required. And the second one is about the role of technology. So as we know, because day by day the technology also increasing, many even now we are in the era of open AI, correct? So everywhere, whatever you want, even you want to work something, just type in there on ChatGPT or otherwise open AI, it will give you the exact idea how you have to do. Means it's not wrong. You have to use ChatGPT in which you can take the suggestions, but you should not use as it is. Correct. Being an academician, we should obey the ethically. It's very important. So we have to follow that, and we have to take that guidance with some suggestions we can take, and in which way we have to take it forward. You can take, and you can, by using many AI tools and other techniques which we have available, that you can take and you can work on that. So, but we have to come up with that particular problem will be whether the problem is going to resolve or not. So like that, you have to link. So everywhere, every time, whenever I used to talk, I convey to all the people, even if it's a faculty or student, whoever are there. First, we have to follow like a particular cycle we have to follow. I call it as a PDCA cycle. PDCA cycle means in our activities also we have to follow every time, like plan, do, check, and achieve. So this is called PDCA cycle. So even earlier I also called it later, means this is a general cycle, PDCA cycle which we call it as plan, do, check, and achieve. Like this we have to follow. That means what exactly PDCA cycle? It's a continuous process. Means you have to plan and you have to do. Means you have to do the background study like that, and you have to come work on some idea whatever you're having, and after that you have to you have to check whether it is correct or not. How you have to check? With some references, with the works done by other people. Like that you have to take, and you have to study, and you have to do some literature, and you have to compare with that, and some papers also you can refer, and you have to check with that, and present current year, who are the people, either it is national or international, who are the people working in this domain, like in your exactly your idea what you're having. So like that you have to think, and you have to work on that. So like that you have to check every time you have to check. And then the final one I call it as A is called either action, or otherwise it will be achievement. So whether you fulfill, that means whether you have reached it through your check, whether your action is completed, or in which way you want to achieve. So that also you can think, and you have to work in that. So in this direction here, the healthcare challenges when we talk, because we are seeing day by day, correct? Whether you are working on a particular technology, whether it is efficient or not, you have to check, right? You have to see first, and you have to check, and whether it is precise or not, because nowadays no one having time, right? I can say, means don't take it wrong, because patience is very important. But nowadays, with respect to the technology, with respect to the social media, what we have, many people want every time. It means everyone need urgently, right? Means, just I'm saying, not everyone, but many people, correct or not? Means they want immediately. So, and how exactly? And that if you suppose you are done, okay, if you give the elaborated 10 pages or 20 pages of write-up, no one, means how precisely you are putting it, means how easily, just simple, like it's like a plug and play, like that you have to come up. So in this, like a mobile is there, so through app, like that, which app and how it's going to be. So even if you want to work on a particular app, how you are, suppose you have some idea, that also you can access through OpenAI, and you can seek information, and you can work on that, and you can come up with the sun. So you have to be, with respect to the outcome what you are expecting, based on that, how easier way you can put it onto the paper or otherwise into the system, that you have to see. So, and which is here, especially with respect to the healthcare, which it should be easily to accessible to healthcare delivery throughout worldwide. So that is the reason I said through either it's national or international. You have to think in that. Next, coming to the, as per our faculty development program, especially we are concentrating on the signal processing and communication impact. So here, how exactly you can showcase, that means whatever the model, either it will be signal processing, which type of you are using, that means which method you are going to use. Okay, either it is time or frequency, whatever you are taking. So with respect to that, how exactly, and the communication, and how exactly the diagnostic system, or otherwise the monitoring system, or otherwise the treatment system, in all these areas, how you can correlate your expertise, especially from signal processing and communication techniques, right? So from these domains, how you are going to correlate, especially in terms of a signal processing like ECG or EEG, like that you have to work. Okay, so in that way, if you work, it will be easy for you. So like that, you have to see either it is in the diagnostic part you want to work, or otherwise in the form of monitoring the exact test, whatever you're taking onto the monitoring devices, or otherwise either with respect to the treatment. So like that, you have to work out. And coming to the sensors and signal acquisition. So here nowadays, because everywhere it's a smart, right? I can say it's like IoT and smart technologies, right? So smart technologies. So smart technologies, how exactly? Without the sensors, we can not say is it smart, correct or not? So there are many sensors available, correct? So many type of sensors like wearable sensors, biosensors, and so many. Even if you want to work in agriculture, so many agriculture sensors also, humid temperature, water, moisture, so many sensors are available. In the similar way, here also the wearable sensors, even nowadays we are the gadgets, whatever, even it is a mobile or the smartwatch which you are wearing, right? It's already having such type of sensors, right? So through these sensors, that's the reason you can also check every time how many steps you have done per daily with that particular day, or otherwise the blood means how exactly the heartbeat is taking place. That also you can see. Even the pulse also, how many seconds is exactly it is taking, how many pulse it's taking, heartbeat also you can find, right? You can check all these things. So all these are already there, implanted, or otherwise sensors tailored, especially with respect to the health monitoring. And nowadays, even the sensors we are getting, like even without any blood samples also, we are going to give the sugar as well as the BP, blood pressure, also can be monitored. So these also available. So in these, how exactly you are going to work, right? So these are the very important sensors of what are available, especially here or international. You can have to check because already available, but you have to see in your work how exactly it is useful, right? So first we should have aware of that, and then how we have to use it, that also we have to check, and we have to work it out. And especially signal acquisition. So the main signal acquisition challenges this, because this is the most important point, especially when you're working with the biomedical signal, right? So in this case, especially noise, or otherwise when we talk about noise, or otherwise artifacts, variability, like a key, these are the main present key challenges in obtaining the clean and reliable biomedical signals. So that's the reason, even if it is MRI or CT scan, so they use a closed loop, right? So here, how exactly and in which way? Even there are so many drawbacks also in the current system. So you can check, and you can work on those current systems also, and you can give some additions to that also, and you can work on that, right? So this is another signal acquisition challenges which we can see. And signal conditioning, especially the conditioning, this is also very important. The signal, like just like we can call it as amplification, like filtering, improving signal quality. So what exactly now, this is very much important, especially recently I'm working on speech processing, like text to speech and speech to audio voice, like text means from image to text, and then text to speech. So in these cases, sometimes due to some lack of data, like information, like a missing of some information, so that there, how exactly, and even if it is missed also, how we can amplify it, especially based on the previous and the next. So like that, we also, people are working on that. So you can also think in that speech processing. So many tools are available, even the so many sensors also available, and even so many theses also available. You can just refer, and in which way you can work, and you can see, and you can carry forward that work, right? So this is about the quality, especially about the signal quality, and enhancing subsequent signal processing steps which you have to follow. Everything we have to do, correct? So other than our traditional learning, how exactly you can work, because now we are in the era of open AI, right? So you can also take suggestions from ChatGPT also, right? It gives very excellent inputs you will get from there, right? So coming to the promise of advanced technologies. So here, when we talk about the promising advanced technologies, here I can say that healthcare tech transform like advanced signal processing and communication when we talk. So transforming healthcare, especially the remote monitoring. So it means enabling remote monitoring. So everyone are calling, even AI also they are using remote monitoring. But how exactly? Because there will be some, even the present traditional work also, even by using AI also, they're having some errors. So how we have to overcome that, how we can modify those signals, how we can monitor. So like this enable these things you have to work, and exactly because in remote areas we don't have that network, right? So how exactly without that how we can work out. So these things you can think, and how we can strengthen the signals, and how we can get reach to the rural areas also we can think, and personalized treatments also, and improved diagnostics. So these are the major areas, means healthcare problems where you can work. So the key technology drivers here, I can say, as I said here, the rise of AI, IoT, AI, and sophisticated algorithms are driving this transformation. That means we have to check exactly the present current, how exact current system, how exactly they are working, what are the drawbacks. Until unless we don't see, we can't go ahead, correct or not? So first we have to check what are the drawbacks and how we have to work on that. So based on that, that means until unless you won't do some background study, you can't go ahead. Even you can't ask ChatGPT also. So at least first we have to do some review, and then we have to go to and ask some ChatGPT or other senior professors who are already available. Even you can work some initial study, and you can take that to your professors and you can ask. So like that also, or your colleagues also you can discuss, because always whenever you want to do some research individually you can't, right? So we have to take some suggestions. So you have to interact with the people outside world, right? Even outside world means not only from our the bounded area. We have to reach to the university, like nearby university, whichever are the technical universities, and even other professors who are working in this domain, or even if the medical field also, you can go and meet with the who are the doctors are available, in which way they want. Means they are already seeing, because they know many problems. We once, until unless we interact with them, we won't get that idea, correct or not? Until we see that problem, then only we can think on that, correct or not? So these are the many various areas are there. So in this way you can think, and you can interact with people, and you can come up with the solution. So this is what I suggest everyone. So please think on that, and you have to go out, then only you can work on that, otherwise you can't, right? So these are the basic things we have to do, right? So when we talk about the healthcare, how exactly we have to define the signal processing, especially in healthcare. So as I told earlier in the initial also, right, signal processing application, like exactly where exactly. So this signal processing, so especially in involving analyzing and interpreting physiological signals, like psychological elements, how exactly, like ECG and EEG, extracting meaningful information for diagnostics and monitoring. So how exactly these things to be used, and how we have to work out. Okay, so these things are very important, and we have to work, and we have to check, and we have to see how exactly. So not only about only the monitoring purpose, we can also check with the physiological limits how we can interpret. So that also is very important. So how exactly we have to see, right? So these things we have to work, think, and we have to work out. So like this, you people also go through and check one by one, or interact with the people, and you can check. Okay, so like this you have to work out. Coming to the second, communication technologies integration. So how exactly, like as I said, communication means we have to, means how we exactly the information, like here I given the point is communication technologies efficient data transfer, means efficient data transfer between patient, means health, not only with the patients, even healthcare providers and medical devices, even how, because when we want to work in real time, so in especially in real time, without feedback we can't work out. Even in our education also, like even we all are academicians, even, right? Even while teaching also, while we're doing some, we have to get the feedback. Means we are teaching some, suppose we are teaching some topic, like suppose um, Suppose I'm working on, suppose I'm teaching something NLP, right, natural language processing. If I want to work on sentiment analysis, how exactly, if I taught something, whether the students reached to them or not, that also we have to think. I mean, how much, if they reached, how much they reached, if suppose students want to work on that, how they are going to work, right? And if we give some practical, means the practical example in front of them, then it will be easier. Like how, just simply like we can take some Twitter messages, we can take Twitter comments. So on a particular issue, so we can take some Twitter comments, and based on the Twitter comments, how many are giving positive, how many are giving neutral, how many are giving negative. So based on that, like this is one of the social media application. So like this we can think. In a similar way, here also, even even if we, while teaching also, whether it is reached to them, so we do some survey, or otherwise we do some Google form, or otherwise like that, we can share and we can take the feedback. So that means we can rectify whether it is reached to them or not. We'll understand. If it is not, what we do in the next topic, we can change, we can modify it, right or not. So like that we do. Okay, so these are very important. Okay, so like electrocardiologist, these all cardiograph, all these things are very important. So, okay, especially when we talk about signal. So how exactly it is working. So these things we have to see. So when come to the part 2 here, advanced signal processing techniques. So here, biomedical signal processing, especially when we are talking about healthcare. So here we have to think about the biomedical. And here now the outside, many people are working on biomedical signal acquisitions, biomedical signal processing. So many, even in India also, many people are doing the research, especially in this domain. So you can reach to any multi-specialty hospital. You can go and check with any doctor who are the specialist doctor who are working, especially with these ENT, or otherwise ophthalmologist, or otherwise other cardiologists also. You can go and meet, they will give, even pulmonologist, because pulmonologist is also very important nowadays due to lung, because without knowing, because so many issues are happening with through the lung process also, especially from the COVID time onwards. So these people, means once you go and meet, you get the ideas. Even now, even oncologists also you can meet, because because especially in terms of chemo, like cancer treatment, initial, we can find out the problem and how we can rectify it. Initial stage itself, we can identify and we can detect the signal. So these things are very important. So here, especially biomedical signal acquisition is very important in these domains nowadays. So many people are working on this. So especially when we are working on this, like high resolution sensors, especially we have to use these, especially playing a pivotal role, like we can say, capturing accurate physiological signals, like psychological signals, like how exactly, that means enabling precise analysis and reliable diagnosis. As I said, right, we have to detect initially, means at the initial stage itself, we can detect and we can rectify that. So we can save many lives also. So like that, the people, doctors also looking for that. So they know the medical part, they can take care, but even through the electronic part, like the signal acquisition, biomedical signal acquisition and all, so they don't know in detail when it comes to the technology. So we have to help them. So until unless we interact with them, we won't get that. So I request everyone who are working in this domain, you can interact, you can reach to any multi specialty hospitals, and if you know, or others, you can take the appointment and you can meet with them and you can get the information and how exactly. But you have, before going to meet them, first you have to review something, means some initial basic things, how exactly you are going to work. Like that, you do some basic background study and then take that to the doctors. That helps you a lot. Okay, so coming to the other one is noise reduction. So we have to work on that, correct? So signal processing techniques, like such as filtering and artifacts, like especially artifact removal, like minimizing noises, like many techniques are available. Independent component analysis, many things are available. But other than that, how we can come up with this and how we can do that? So especially because nowadays data is also everywhere, data is available, correct? So even data analytics also taking place, correct? Data science also. So how exactly you are going to collect that and how you are going to use it? So you can, once you meet the doctors, officially you will get the data from the medical data and you can work on that, and accurate interpretation. And even because this itself is the collaborative research, right? You can also acknowledge those doctor names also in your research. So like that means where exact that hospital also name also. So like that, how exactly, because here the data is precious. You won't get data directly, correct? Even if you get data, is some sample data which is available, you'll get. But with that, you can't do anything, correct? Even you get some equipments also from the hospitals. Once you build the rapport with those doctors, later you can work with those machines and you can get that support also. And even you can also include those doctors' names also in the paper publications, right? So like that also you get the more paper publisher. You can also publish more papers with the support of those doctors also, because you are getting that data, right? So that is also very important. So because data itself is a gold nowadays, we can say, correct? So this is about the biomedical signal, how exactly we have to access. When we talk about the time domain analysis, so here, as we know, statistical measures, right? Even we do this, correct or not? So just like all these things we do, but just only why we do for a the signal amplitude, duration, and variability. How exactly it is changing. That these things are very important. Even if it is a basic, but how exactly you are using in this particular system, or otherwise the application which you are going to work on, that you have to think and you have to work on that. And next one is correlation analysis. How you are going to get the relation, means you have to access the relationship between the different biomedical signals for comprehensive insights on psychological function. Like even how exactly when it comes to real time, correct or not? So in real time, how you are going to do with the sample data, like that you have to insert. So these things you can correlate, and you can this correlation analysis you can work, and you can work on this biomedical signals. So like this you have to work on. If you see the heart rate variability, if it's just simple example, simple case study. So this is especially they use the by using the ECG signals, right? They correlate, that means automatically nervous system activity to cardiovascular health outcomes. So by using this, they can predict. But how exactly you can give? That means here, especially the heart rate, we can say call it. Actually, we technically we call it as arrhythmia, correct? So we can call it as the heart rhythmics. So especially how this uh, heart rate rhythm is going to be. So even if it is irregular heartbeats, how you can conduct, right? So due to these irregular heartbeat, like we can call it as arrhythmias, right? So these arrhythmias itself cause the heart attacks, right? So these things you can suggest, you can suggest patients or otherwise normal persons also, because how exactly it's coming, because nowadays due to stress or it's coming, right? Even for a young people also it's getting. So how? So this can be check. So you can work on that. How we can detect this irregularity? That means heart rate, the how exactly the heartbeat irregularities of the heartbeat can be. So we can call it as the rhythm of the heart. How you can calculate the rhythm of the heart, right? No need of going to ECG to hospital to check with through ECG. You can come up with your some sensors. You can work on that. So like this also you can work and you can come up with the system. So like this, if you give, so you'll be so everyone can check, correct? So like that you have to think and you can come up with that. So this is about time. And when we talk about the frequency domain, especially here, converting especially from time domain to frequency count, right? For time domain signals to frequency component. So here especially the spectral characteristics plays important role. So here we use Fourier transform, right? Various Fourier transform techniques to be used to convert, right? This time. So not only that, even power spectral density. So here analyzing the distribution, already everyone knows here, correct or not? So how this power spectral density also. So you correlate now. So you can think on a particular application, or otherwise you can the particular gadget you can work with some sensors. How exactly you're going to get that the rhythm of the heart? How means you can check when they're getting angry or when they're getting nervous, how exactly the heart rhythm is taking place. So with this, how the abnormality means you can detect the abnormalities and pattern in EEG. No need to go to all this. You can check, you can work on that. So like this, if you work and you can work on this, you'll get even you can go ahead for further research studies also. So like this, what are available that you can identify, and where to, especially where exactly to work, that also you can think, right? So like this example, simple example here, the case study I given here, like EEG analysis for epilepsy detection. So here using PSG, like power spectral density analysis for identifying epilepsy spikes. So here, and scissors shown in frequency domain EEG, signal processing. So this is especially with the help of EEG, right? But even you can also come up with some sensors. So how exactly we can rectify, how we can find out the initial stages. So if you do that, and if you give this one, everyone will go ahead. So like that, you have to think, because which is useful to each and every person. Okay, so even they are in stress or without stress, even they are in work, normal work conditions, even they are good also, even if they're having good health also, we can suggest. So everyone nowadays, because everyone are health conscious, so if we suggest, everyone will go ahead with that. So you can think like that, and you can work in that particular area. And you can adjust. It means it's not work like already you have the technology, right? You already have the expertise. So just you need some logic, you need some expertise, you need some application, how it should be come up. Okay, so like that you think, and you can work on that. So like that, if you go ahead, you will get a compulsory, you will be the top. And you can also start your own startup, and you can go ahead with that. So time frequency analysis, here the short-term Fourier transform. So by using here short-term means these are the steps you have to follow. There is a reason I just given as a simple flow, which already we used one of our device, which we used even in for the simple checking of that. And not only that, later what we did, how exactly the data will be encrypted, means the data will be secured. So for that, we are taken through blockchain. So this is one of my PhD student worked on this for the next stage, that is how to secure the data. Because this is a patient data, means many patients are available in, if suppose many patients data is available with a particular hospital, right? So we have to take securely, we have to be maintained. So for there we used blockchain, how exactly the blockchain helps to control, means maintain the security with the different blocks, how exactly. So that is one of my student done for the extension of that part of this. So here, the short-term Fourier transform, analyzing time-varying spectral characteristics of signals, so like useful for non-stationary signals, and even wavelet transform, like multi-resolution, like analysis, like capturing both frequency and time information, ideal for transient signal analysis. For that, we have to work. And next here, this all by using all this, like muscle fatigue, to find out the muscle analysis for muscle fatigue. So using wavelet transform on EMG to detect changes in muscle activity, identifying onset of muscle fatigue. So here, just think now. So you can think in like this, how exactly we are working. So here muscle fatigue also. So all these things you can come up together, and you can work on that. So this is the like this, if you come up with some idea, and you can ask ChatGPT, it will suggest you a very good deliverables it will give you, but you have to work on that, how exactly and in which way. But without the real-time data, you can't do that. So interact with some doctors, and you can work on that. Okay, so these are the simple examples and simple concepts which I've thought to give you or everyone here today. So next one is signal processing for personalized medicine. So here, as I said, here pharmacogenomics, here especially this analyzing like how exactly the genetic variations, like the drug response, how exactly the drug response take, because patient to patient it varies, right? So that also you can work. So this is also another important parameter, not only parameter, even the issue people are facing in hospitals. So this is also very important. So these things also you can get from the hospital once you interact with it. So like this, the medication regimens and to individual, so different patients, when different age group patients, how exactly, even with the same bed group patients also, how exactly it is changing. So these things also you can analyze. So with this, you'll get some, you can analyze the genetic variations. So, and even you can also predict the drug. Even this helps the doctors, how they can rectify. So like that, you can work, and you can come up with that idea, and you can also suggest to the doctors. So like this, we can help many doctors, many hospitals, right? And other one is like real-time monitoring patients. Like this is about the physiological, we can call otherwise psychological monitoring. And here, the real-time monitoring patient response on to therapies, like adjusting treatments, like based on individual feedback. So based on the individual patient feedback, how exactly the therapy. So immediately the doctors also can take. So this is what I was saying, like the physical, I mean, if we have the real-time data, so this also easy for us to get, and even doctors also can understand easily. So why can't we come up with all these things together? Even some apps are available. I'm not saying that they are not available, some, but they are not exactly, but if they're, because it should reach to each and everyone, right? So how exactly? So like that we have to come up. Okay, so next is simple case like a personalized cancer treatment, right? So by using these techniques here to monitor the tumor responses, like for especially for chemotherapy, whether because either it is initial stage or what stage, we can also suggest to them, and even doctors also can suggest them. So with through this application, and they can work on that. So like this, adjusting the treatment instead of directly going to stage 1, stage 3, like that, we can overcome that, and we can save many lives also. But, right, with this, a better outcome also will come. It's not only for the doctors, even we can also, it helps many people, correct or not? So like that, you can think and you can work on that in this domain. Okay, so that's the reason I said biomedical signal processing is very good nowadays. So everyone are working in that domain. So you can also think and you can use in that different applications. But you have to interact with the doctors. So without their support, you can't, because we won't we won't know exactly what is happening, correct or not? So like that, if we interact and you can work collaboratively with the doctors, that helps a lot, each and everyone. Okay, so that is very important. So how your expertise helps the society, that you have to think, being because already you have some technology, right? So you have the expertise, so how your expertise is helping to the society, that also you have to think. So this is very important, right? So next, feature extraction and machine learning. So here the feature extraction, when we talk about feature extraction, here especially identifying the key biomarkers. So here the critical biomarkers with psychological signal, like physiological or psychological signals, these biomarkers can indicate disease states or predict health outcomes. So like cancer treatment, or otherwise the fatigue, muscle fatigue. So all these things, or otherwise the heart rate rhythms, how exactly, how they are fluctuating, how they are signal is changing. These all things are very important. So these things like means, no, I'm not saying you to work on all. You can take one such parameter indicator and you can work on that indicator, and later who are the people working in that different indicators can come up together also. So like that we can work. So once we work on particular indicator, and this next you can go with the other indicator. So like that you can work collaboratively or with other people also, right? So like this you can, and predicting like predictions. So already we know everyone are working in machine learning, I know. So for prediction, especially for predicting predictive analytics, especially machine learning is very good, right? Already we have many machine learning algorithms, right? So which we can analyze by extracting the features to predict potential health risks, right? So that is also there. Even cancer or brain tumor, like these things also can be identified. Even the skin, nowadays the recent skin diseases, skin cancers also coming nowadays, so that also can be identified. And with these techniques, like many techniques are available. With these techniques you can SSFT, SVM, so many techniques are available. By using these techniques, we can, it's like enabling proactive interventions, and personalized treatment can also be suggested. So like this we can help doctors, how exactly, and we can come up with a system, or otherwise some dashboard, or otherwise some application like that you can think, and we can work. So these are the feature extraction and machine learning techniques. They just now see here, see my flow, how exactly we are going one by one, right? So like that you can also think and you can work in that domain. So like if suppose if you see the ECG analysis for arrhythmia detection, so like as I said, like a heart rate, like rhythm of heart rate. So here the automated arrhythmia screening, like the signal processing algorithms, automatically detect irregular heart rhythms from ECG signals, right? So it means with this, this is there, but this is, you require the ECG. You need the patches they have to put on the chest, and they'll take with them sticky patches, correct or not? So, but instead of that, like some electrodes they use to get that, correct or not? Electrode patches. So, how you can come up with that? So, like that, you can think and how you can rectify. So even which is easy to which is easy available to each and every person. So you can think in that, and you can work in that direction. So which will help to reduce the burden on clinicians, like improving the diagnostic accuracy also, right? So like this also you can think and you can work in this direction. And improve patient outcomes, like early detection and timely intervention, which helps significantly improve outcome of patients with athenia problems, correct? And by monitoring through smart devices, and even the which medication to be taken, that also can suggest with the help of some doctors, right? So that also you can think, okay? Because nowadays online doctor availability also there, right? Few apps already there, right or not? So through, but altogether very few apps are there, but not in real time. They are not also useful because they are not using it like that. So by through smart devices, like you can plan such devices in real time, which one will work effectively and precisely and accurately. These things are very important when you're working. So think on this and you can come up with your ideas and you can plan and you can collaborate with some doctors and you can work. So part 3, as I said, the cutting edge communication technologies. So here wireless communication, just I'm giving some point because already you know here Bluetooth, like short range communication we use, like transmitting real time health data to smartphones or other gateways we can use, because already now in many hospitals they are using it, right? Even through Wi-Fi also, because here it required a high bandwidth communication, enabling remote patient monitoring, telehealth consultations already, but not full-fledged it's working, but it should be taken in future. So but which is easier to reach to each and everyone, means each and every person, okay? So like that you can plan and you can think. And cellular network, like now we are in 5G, so already reached long back, but in existence it is there. So wide area coverage, so supporting remote patient monitoring, telemedicine, but even now everywhere everyone says, but in rural areas it's still not available with high reliability and speed. So these things are very important. So how exactly the telemedicine with this high reliability and speed, how will reach to each and every person, and that is also important. And not only that, even in the ambulances also we can think and we can plan like such, and we can save so many lives, right? So even which is available even on the highways, like or otherwise like outer ring roads or highways, these things are very important, because in some people met with some accidents, and how we can save their lives, yeah, and how the medication can be taken in real time. These things you can plan and we can think, and we can connect doctors online and can take, because already they are doing, but in real time existence 100% is not there. So I know, but 100% everywhere it's not there, but at least we can reach to that point, we can work, okay? We can think in that direction. And wireless body area network, like continuous health monitoring. So wireless will enable continuous monitoring of vital signs, like using wearable sensors, providing real-time data, like we can say here, like patient health status and real-time data, strength of how exactly we can help them to get to rectify that. And even some people may, because nowadays many people, many elderly people are required now. So how we can help them, right? At their critical situations, how this will help. So in that way, because without without some attenders, how we can, because family attenders, how we can help them, these things we have to think and we have to work on that. So these are very important, so we have to think on this directions and we have to help them, okay? So we have the technology, and how this technology will reach to each and everyone, we have to think, right? So like this we have to work, and continuous health monitoring should be taken care. Okay, so coming to the data security and privacy, so this is very important, as I said. So the data security here already, the data security is the one of the most important, right? So securing communication means how exactly our communication protocols to be secured. So this is also very important. We have to check exactly how it is helping, and because the patient data is very sensitive data, so we have to take care of this important. And through this wireless body area network, and this is very important as per the regulatory, as you know, because the ensuring confidentiality is very important. And the regulatory complaints, like HIP, already HIPAA is already doing that, everyone knows, right? So here, like like already you know, right? this is HIPAA is nothing but the Health Insurance Portability and Accountability Act. So these are very important. Under this act, how exactly this data is protecting these things are very important. So this especially because many people throughout world they have to follow this. So health insurance portability and accountability is very important. So as per this act, we have to be followed. So even the doctors, even the technical professors, academicians, or researchers, whoever are working, they have to follow this. So we have to be very careful while working with all this data, healthcare data. Okay. So coming to the next, telemedicine and remote patient monitoring. So here in this case, especially here, I given 2 points like bridging the distance gap. So bridging the distance gap means here the telemedicine platform, as I said, how we can connect the patients with healthcare providers remotely. So as I said, in remote rural areas, how effectively we can help them, right? And easily to reach to each and every person, correct? Even in rural areas. So this is very important. So improving access to care. So we have to think on that. So through this advanced communication technologies, so we have to bridge this distance gap. We have to do that. So we have to work on that, especially in terms of telemedicine platforms. So we have to think and how we can connect patients with respect to the specialized doctors, especially in that particular area. We have to think. So this is another point. And real-time data transmission benefits. So this is the real-time data transmissions from wearable devices like enable timely interventions and personalized treatment plans, improving patient satisfaction. Because we have to, without the patient satisfaction, we can't do, right? Even doctors also, every time they interact with the patients and they'll take the feedback, how they are feeling, how they means how you felt in the night, in the morning, or in the afternoon, or in the evening. So these all things, because of different time intervals, different feedbacks are very important, especially when they are using with the medications. So these, especially, and as I said initially, also patient to patient it varies, right or not? So that is also very important, and how that medication, how that medicine is taking, affecting with the people, that also they have to take it. So through this, the feedback they can do. So all these things, how the doctors are going to maintain. So that is again the problem, right? So in this, like these things, so if you come up all this together, so this is easy for each and every doctor also can reduce, and they can they can utilize the time to cure many people, right? Because nowadays they are treating only very few based on their time, because because this all are not available. If this is there, then they can treat many people, correct or not? So this is very important. So that's the reason many people are working in this domain. Okay, so remote monitoring and diabetic patients, like continuous glucose monitoring, this is very important for dialysis patients, right? So this is very much important nowadays, because nowadays many people, due to stress or strain, many people are affecting with the diabetes, right? I'm not saying, but many people are undergoing this medication. So this is required nowadays, right? So for that, it's a continuous monitoring, continuous glucose monitoring systems. This is very important, very much important. So smart insulin pens and CGM, like continuous glucose monitoring devices, transmit glucose levels to healthcare providers, right? So this is very much important, and how you can come up with this, that also you can think and you can work, allowing for timely adjustments like to medication and diet to prevent emergencies. So they have to undergo with the different timing, like in the early morning or after the food, before food, how they have to take care. And after, even if they are in journey, how they have to take care of these things is very much important. So this, like this also you can work, you can think, and you can plan on this area also. And enhanced patient engagement with mobile app. So because, and even through the app also they can interact with the doctors or the technical person who can help them, right? Or the family attendants also can interact with that. So like that, we have to mobilize many people in this particular direction. If we come up with this, and how exactly it is useful to them, and how not only to the particular patient, even to the doctor, even to the family attendants also, because they can guide through that, and which to what medication to be taken, that is also to be provided immediately. Means it should be like we have to maintain such libraries into that app itself, so it can pop up and it can highlight to them. with a different, even if they have that, it can also show in that particular application. So like this, we can manage their diabetes, and we can treat many people, even not doctors help, and even their family members also help them. So we can also come up like such applications. So you can think this is another case study where we can plan and you can work on that, right? Diabetes patients. So this is also another important recent, many people are undergoing these problems. Okay, so this is another area of in this, particularly especially in healthcare. And here the specific healthcare areas, like the major means mainly nowadays, because the low age group people also affecting with this cardiac arrest, right? So that's the reason the ECG analysis is very much important, like a heart rate, like the, as I said, arrhythmia detection. So like we call it as heartbeat rhythms. So this is very much important nowadays. So we can come up with that. So the ECG analysis, like remote monitoring or improving diagnosis and management, how we can come up with that, how we can check, and how they can control themselves, or how they can divert from that situation. So these things we have to come up with. So like sad, stress, or happy, these all movements, like through face, even we can interact, we can combine, like the application which we can work, like even it can see the face, like our facial recognition, because nowadays each and every mobile having facial recognition, correct or not? So through that also we can give that, even if they are sad, even if they are stressed, or even if they are not feeling well, so it can detect and it can suggest. So like that you can plan and you can work on that. So like this all together we can come up with that. And wearable like cardiac monitors, like continuous ECG, detecting irregular heartbeat, providing a real-time alerts. So as I said, and early detection and of atrial fibrillation, like wearable ECG monitors, like signal processing, early detection of this uneven heart rate, irregular heartbeat, so which can help them to, especially from preventing strokes. So these are very important, very much important, especially when we talk about cardiology, right? So this is the one application which is at present, which is very much important to each and everyone. Next, neurology. Yeah, this is also another important area, like because many people, due to stress or otherwise due to hypertension, many people are affecting through some problems, like seizure detection, like sleep staging, cognitive monitoring, like many problems they're affecting nowadays. So neurological disorders, these are also affecting. So even not only due to stress and that, even the because nowadays everyone are using many gadgets, and the technology around us means that electromagnetic waves and the electromagnetic signals which are surrounded us are with many gadgets, right? Everywhere you go, there is a technology, right? Even with Wi-Fi or otherwise network or mobile data, everywhere we have the same signal strengths, right? So they are continuously, you are sitting with the laptop or systems or otherwise mobile gadgets, you are working, you are receiving the signals from satellites, right? So all these things are very much, because this is the technology is growing. At the same time, we have to maintain that difference, the distance, right? When we do that, when we maintain this parallelly, then it will be good, right? But due to this, the effects are taking place. So we have to control, and we have to maintain, and we have to give the we have to interpret, and we have to predict them. So right, so like that we have to come up with this topic. So like another one is called brain computer interfaces. So like this here, the translating brain signals into commands, like assisting paralyzed patients, like many people nowadays affecting due to this neurological disorders. So how we can control these external devices through this, that also we can come up, and we can suggest and we can help people to reduce these problems, right? So especially the stroke rehabilitation, like this helps many people to recover from promoting neural recovery and helping regain motor functions and all. So we have to think, and we have to suggest them, and we have to come up with that such type of systems or applications we can think, and we can work together, right? So this is another area, that is neurology, the application where exactly required our biomedical signal processing and communication. And one more important, that is from COVID time onwards, like everyone knows, right? Pulmonologists. So here the pulmonology is here, right? So here the respiratory sound analysis. So detecting respiratory diseases like asthma, COPD, like already we know from COVID time onwards, everyone knows this, right? Monitoring respiratory function, improving early intervention. So this is also another important point where we have to work, and we can think on this and we can work, right? So here you can think on this, like even the respiratory sound, based on the respiratory sound also we can think and we can work on that. Okay, so this is another important, especially in pulmonology, right? Due to with this, how exactly the problem can be, like what we call it as a chronic obstructive pulmonary detection disease can be identified and can be rectified. So these things we have to think. And sleep apnea detection. So this is also there, like analyzing sleep data to identify apnea events, like improving diagnosis and treatment. So here also another important point. We can also work on that. Even not only this, even the snoring also can be rectified. How exactly, based on their activities and based on their sleep and based on their stress and based on the hypertensions and all, also can be checked. So all these things, as again coming to the bio, we have to, with this biomedical signal processing, with the help of this we can work and we can treat, we can come up with that. Okay, so this is another one. And case study, like remote monitoring of COPD patients using wearable sensors and signal processing, remote monitoring COPD patients, like preventing exacerbations. So this is also can be done, so remotely also. So think and we can work on that. So there is another application where we can work on this pulmonologist. Next, diabetes management, as I told earlier. So real-time glucose monitoring is very much important. So especially for hyperglycemia and hypoglycemia, optimized treatment like this is very important. If, with the different time intervals, and even the insulin pump integration. So these also the glucose, based on the different time intervals, different glucose levels also to be used. So improving glycemia control or enhancing quality of life. So these things especially to be worked on that. So these are the other applications, and here they especially the closed loop insulin delivery. So integrating the glucose, continuous glucose monitoring with insulin pumps, automated insulin delivery. So elevating burden on patients. So we can monitor through this. They can self care also can be taken care. So through this they can also take care of that. But many people won't do, but it can suggest them to control. So like this, these are the various applications where this biomedical signal processing is working. Okay, so help with some smart assisted device or the application where we can work. So when we talk about the challenges and future directions, so especially as I told you, data security and privacy concerns. So cyber security threats is very important because now we are in that era. So healthcare data is vulnerable, and cyber attacks. Many people nowadays, cyber attacks are happening everywhere. So robust security measures are crucial for this, protecting patient information and maintaining trust. So we have to work in that way. So how you can come up with your application. So as already I told you, many applications are available, but they are not that much because due to these drawbacks. Okay, so we can work on that and we can increase that. So compliance with regulations like HIPAA and GDPR is essential. So these are the regulatory compliances, so which already have been taken care. So you have to see all this and you can work on that. So these are the privacy concerns we have to be in and check, and we have to work on that. Okay, so interoperability and data integration. So here standardizing the data formats. So how we are coming up, and we have to be standardized, which means by following all the regulatory. And that's the reason I said once we collaborate with the medical doctors, so with their support we can do that. So we get maximum support from them. So all input, whatever I'm saying here, all this data integration, everything can be easily done once we have the collaboration with the medical doctors. Okay, even if we have the technical expertise, if we take the medical expertise, then it will support to get more publications, even more support and more we can reach to the each and every person with some application or with some dashboard or with some devices, smart devices. Okay, so this is about the one. And the second one is integrating with EHR. That means electronic health record. How we can integrate this our the smart devices with this. Okay, especially providing holistic view of patient health and facilitates informed decision making support to all the people. Okay, so these are the things which are very much important to incorporate in this particular application. Okay, and future trends. So here, these are the future trends, like as I told you, artificial intelligence in healthcare, AI-driven diagnostics like personalized treatment plans, improving efficiency, enhancing patient outcomes. So that also can be taken, and Internet of Medical Things. So this is very much important nowadays because the smart device, whichever you are calling, so we can trade now. We can call it as the Internet of Medical Things. So we can collect like the medical devices, like the smart devices, whichever you are taking with respect to the real-time data and remote monitoring all together. So this revolutionary care delivery will be taken place. So people are working on this now. So you can also think and future of signal processing, integrating the signal processing with novel sensors and technologies, like creating personalized proactive healthcare. So now you think on all these points and you can work for your future and applications or future research works. Okay, so in my concluding through my conclusion, so here how exactly, so recap of key advancements here, the summary of major points. So advancing signal processing and communication technologies are transforming healthcare, as I said. So I've shown some examples. Enabling personalized, proactive, and connected care solutions can be possible, and impact on healthcare ecosystem, improving patient outcome, reducing cost, and enhancing the delivery of care. Okay, so this is ultimately the most important part. So call to action. So embrace the future. So here, as I said, collaboration and innovation is very much important. As I said, you can collaborate with many people, like as I told many times today. Okay, so how and adoption of the advanced signal processing and communication technologies. Okay, to help each and everyone. So like that, you have to think, and investing in digital health. So already many markets, already many people are in, already so much of infrastructure already there. So how your idea helps in that domain and can come up with that with healthcare professionals, right? And which can improve that we can take care not only here, everywhere in throughout world. So this helps, this increase the care everywhere, right? So the future of healthcare, personalized precision medicine. So this going to be come up with that. So like whatever the medicine, it can reach to each and everyone with and deliver better care with better care. So it can reach to each and everyone. So that we have to take care. And that's the reason I called it as a precision medicine, personalized precision medicine, and accessible, cost-effective care. This is most important, and even cost-effective. So here the technology, and even if because we are talking about the initial care, right? Early stage. So if you do all these things earlier, so obviously it will be low cost, correct or not? So later means we can't do that, right? So we have to come up with that which can identify, detect, and help the people. So improving healthcare access, ultimately signal processing and communication will enable healthcare for everyone and everywhere, right? So here are my references. With these references, I have come up with this presentation, and thank you for patient listening. I'm sorry if I go fast and okay, if I bore you. I hope I given some ideas to you today. So here is my details. If you want anyone, if you want to connect, you can connect. You can write to me. Okay. So this is what. And if you have any questions, you can ask. Thank you so much.
If you have any questions, please you can ask. Okay, if you don't have any questions, then so thank you, sir. This lecture has shown us how innovations in biomedical image processing, biomedical signal processing for medical logistics, wearable health sensors, wireless body area networks, and secure telemetry platforms like reshaping the future. And also, you have highlighted the challenges: data privacy, scalability, and accessibility, and integration with the existing healthcare infrastructure. And I also extend heartfelt thanks to user for shaping such valuable insights. Your perspective has not only broadened our understanding, but also inspired us to think critically about how engineering and healthcare can collaboratively work together for the social benefits. Thank you very much, sir.
Okay, sir. Thank you, sir. If you have any questions, you can ask. Okay. Please.
Do you have any questions? Please, you can ask. Otherwise, so we can wind up.
Actually,
the
in
call.
chat, I saw one question Rakesh Dasari has given. What is the role of IoT in mobile communication? Yeah. So actually, in mobile communication, IoT is also taking place because many people nowadays they're using it. Like we can say that, like especially when we call about ultra low latency, right? So for especially for high speeds, there you can like massive signal strength. There your requirements there it helps. Like we can take like mission based massive signal strength can be used. So in those places, you can IoT helps there. So like that, it can help. Like if you see even what we can call it as ultra reliable low latency. Like that, people already using it. So like that, you can use with that you can help. And how IoT means this uh, uh, what we can call it as enhanced mobile broadband. There, especially here, the IoT is taking place. Okay, like a massive signal strength to increase that. So there it helps. So like that, especially in 5G, it is using. Okay, sir. Okay, sir. Any other questions?
Madhinarena sir, do you have any question? You are unmute.
No, sir.
Okay, okay.
Thank you very much, sir.